Good morning, students. Today we'll be discussing about the properties of inverse trigonometric function. Remember, this is my third class on inverse trigonometric function. Before that, I have taken two other classes, and there also I have discussed with different properties which are important to know. So I will suggest you please go through the first two classes, then please go through this class because the other two classes are equally important. So here in inverse trigonometric function, I have mentioned it at property 2. So see, these are the properties which are very important. See, the first property which we could see, sine of sine inverse x is equal to x. Beware of the range. The range is always important. So here the range is x belongs to, it's close bracket -1 to 1. So it's in close interval -1 to 1. Second rule is cos of cos inverse x is equal to x. There also the range of x remains same. And we have tan of tan inverse x is equal to x. Cot of cot inverse x is equal to x. Sec of sec inverse x is equal to x. Cosec of cosec inverse x is equal to x. Remember, see the range. These ranges are exactly whatever we have done in principal value branch table. Do not to be worried, I'll be posting this page also along with the video, so we will get a clear idea about the range and the formula. Look at the property 3. Here we have sine inverse of sine theta is equal to theta. Check the range of theta. It should be from -pi/2 to pi/2. Remember, this is also based on PVV table. Second is cosec inverse cos inverse cos theta is equal to theta. Tan inverse tan theta is equal to theta. Cot inverse cot theta is equal to theta. Sec inverse sec theta is equal to theta. And cosec inverse cosec theta is equal to theta. Remember, these properties will only valid when the theta's value are in these ranges. So be careful with the range. Property number 4. See here, property number 4 is very important. Here, the first property says it's sine inverse minus x is equal to minus of sine inverse x, and cos inverse minus x is equal to pi minus cos inverse x. See the range? Here the x should be in between -1 to 1. Property number 3, it says tan inverse minus x is equal to minus of tan inverse x, and cot inverse minus x is equal to pi minus cot inverse x. See the range. X belongs to real number in both the cases. Property number 5 and property number 6 are like this. Cosec inverse minus x is equal to minus cosec inverse x, and sec inverse minus x is equal to pi minus sec inverse x. See the range. Now suppose if we want to prove it, suppose we are proving rule number 1. What is that? It's sec inverse minus x is equal to minus sec inverse x. So here what we are doing, we are taking sine inverse minus x is equal to theta. So sine theta is equal to minus x. Now we are bringing this minus sign along with sine theta. So it will be minus sine theta is equal to x. And we know, as far as our knowledge is concerned in class 11, minus of sine theta means sine of minus theta. That is equal to x. So minus theta is equal to sine inverse x. So theta is equal to minus of sine inverse x. And that's the way we can prove sine inverse minus x is equal to minus of sine inverse x. If we want to prove the rule number 2, see how we can prove it. Here also we have considered cosec inverse minus x is equal to theta. So minus x is equal to cos theta. Check the steps. Similar way of proving. X is equal to minus cos theta. And minus cos theta means definitely cos will fall in the second quadrant. So what we are writing, x is equal to cos of pi minus theta, and then pi minus theta is equal to cos inverse x. So theta is equal to pi minus cos inverse x. So cos inverse minus x is equal to pi minus cos inverse x. Now let's discuss property number 5. It's another important property. See rule number 1, what he says, it's sine inverse 1 by x is equal to cosec inverse x, or we can write cosec inverse 1 by x is equal to sine inverse x. Look at the range. Property number 2, cos inverse 1 by x is equal to sec inverse x, or sec inverse 1 by x is equal to cos inverse x. Property number 3, tan inverse 1 by x is equal to cot inverse x, where x is greater than 0, and tan inverse 1 by x is equal to pi plus tan inverse 1 by x when x is less than 0. So this rule number 3 is very important because we have two different conditions or two different formula. Now if you want to prove the rule number 1, so how we can prove it? Say we are taking cosec inverse x is equal to theta, so x is equal to cosec theta. So in place of cosec theta we can write as 1 by sine theta. So we can understand here theta value cannot be 0, because if theta value is becoming 0, then sine theta will give you 0, and 1 by 0 will be giving you undefined value. So we cannot take theta is equal to 0. So sine theta, the next step is sine theta is equal to 1 by x, and therefore sine inverse, if we take sine inverse on both the sides, then it will become sine inverse sine theta is equal to sine inverse of 1 by x. So theta is equal to sine inverse of 1 by x. So therefore cosec inverse x is equal to sine inverse 1 by x. Remember, we have to always do this verification. See here, x's value should be, if you remember the PBV table, x's value should be less than equal to minus 1 and should be greater than equal to 1. So here if we make it reciprocal, 1 by x is greater than equal to, the sign will get reverse, it will get reverse. So 1 by x is greater than equal to minus 1, and 1 by x is less than equal to 1. So along with these two particular rules we can combine, and then we can write minus 1 is greater than equal to 1 by x and is less than equal to 1. So minus 1 is greater than equal to 1 divided by cosec theta and is less than equal to 1, and minus 1 is greater than equal to sine theta and is less than equal to 1, which is the actual range of sine theta. So in that way we can prove it, like cosec inverse x is equal to sine inverse of 1 by x. Now if we want to prove the other property, that is rule number 3. So we are taking cot inverse x is equal to theta. So x is equal to cot theta and x is equal to 1 by tan theta. So tan theta is equal to 1 by x. Now taking tan on both the sides, it will become tan inverse tan theta is equal to tan inverse 1 by x. So theta is equal to tan inverse of 1 by x. So therefore cot inverse x is equal to tan inverse of 1 by x. We always have to do the verification. So here x is greater than 0. So cot theta is also greater than 0. That means it falls under the first quadrant. So theta belongs to 0 to pi by 2. So that means we can understand that cot inverse x should be equal to tan inverse of 1 by x. I hope you understood the properties. There are more properties and the solution of the sums, which I'll be posting in Edmodo in no time. Thank you.